the parallel postulate, again, postulate being something that is so simple, it is elementary to creating our kind of nice flat geometry. The parallel postulate says this. If I have a line and a point that is not on that line, bless you, I can only have one line passing through that point that will be parallel to my given line. Bless you. And now, if you'll bear with me, put your pencils down a second. But I don't want you to get so hung up on the logic that I'm using and what I'm writing that you lose sight of what I'm saying. All right? So, if I were to draw a random line passing through that point and passing through my line, and let's say I call this angle 1 and angle 2. These lines are parallel. What do you notice about angles 1 and 2? They're alternate interior, so I know that they're congruent. Similarly, if I draw another line over here, and this is angle 3 and angle 4, once again, I'd hope that you'd notice angles 3 and 4 are also alternate interior angles, and they are congruent. Finally, if I threw an extra angle here, angle 5, look at angles 1, 5, and 3. Angles 1, 5, and 3. What has to be true about angles 1, 5, and 3, Lily? They add up to 180. And so now you see why, some of you already knew, why the sum of the measures of the angles of a triangle is also 180. You can pick your pencils back up.
So 2, 5, and 4.
Angles 2, 5, and 4 also will add up to 180 in this diagram, yes. Okay, but as I said before, I'm very interested in exposing you to why things are and not just throwing the property at you and saying, here, just take my word for it. Now, in this diagram, conveniently, I have, ladies, is there a question? Okay. Conveniently, I already have an extended side of this triangle. So I'm going to label this angle, angle 6. So in this second blurb of our notes where we're talking about an exterior angle of a triangle, notice that angle 6 fits that description. It is formed by the extension of a side of a triangle and a side of the triangle. Okay, so in this diagram, angle 6 is an exterior angle. In that blurb, there's also some vocabulary. Oh, I'm sorry, this is skipped over to the other side. Sorry about that. That second blurb is on the back of our notes. Let's address all of the properties all at once, and then look at examples thereafter. All right, so might want to take a moment and copy that diagram over there also, since we're referring to it in that blurb. And as you're copying that diagram down, I know some of you may be done, you'll notice in that little paragraph above where you may have drawn that diagram, I'm also defining remote interior angles. notice what the definition of remote interior angles says. They're the two angles of the triangle that are not adjacent to the exterior angle. So let's be very step-by-step in identifying those remote interior angles since we're doing it for the first time. In that triangle on the screen, what is the angle of the triangle that is adjacent to my exterior angle, angle 6? What is the angle of the triangle that is adjacent to angle 6?
4.
Angle 4. All right, so the remote interior angles are the two angles of the triangle that aren't angle 4, namely
2 and 5.
angles 2 and 5. So if I'm talking about exterior angle, angle 6, angle 2 and angle 5 are the remote interior angles for angle 6. And so, look at angle 6. We talked about how it's adjacent to angle 4. Is there any other relationship that it has to angle 4? Is there any other relationship that angle 6 has to angle 4, Adrian? It is supplementary, so it adds up to 180. Gosh, I've heard 180 before today. Notice that angles 2, 5, and 4 also add up to 180. So, again, do me a favor, put your pencils down a second. I'm more interested in you seeing this logic than driving yourself nuts scribbling it down. Okay, so you know that the measure of angle 2 plus the measure of angle 5 plus the measure of angle 4 equals 180. What else did we say equaled 180 up here?
Angle 6.
Angle 4 and angle 6 also. Whoops. Add up to 180. Look at the equation I have up here. Do you notice anything that I can do to maybe clean it up a tiny bit? Do you see anything that I can do to this equation and maybe clean it up? Zoe?
You can subtract the angle of 4.
I could subtract away angle 4 and notice what we would have. We would have the fact that the measure of angle 6, the exterior angle, equals the measure of angle 2 plus the measure of angle 5, or its two remote interior angles. Pick your pencils up. That's our next property. The fact that the measure of an exterior angle of a triangle equals the sum of the remote interior angles. And now we're ready to flip it back over and start looking at problem 1, where we're finding angle measures in triangles. Before I do, we're still getting from this screen what we need. I'll pause. Yes, ma'am.
I don't see how 2, 5, and 4 add up to 180.
Okay, let's backtrack. Up here, we created this red line so that it would be parallel to this bottom horizontal line. Okay, does it visually make sense based on the stuff that we've talked about previously that angles 1 and 2 are going to be congruent because they're alternate interior angles? Similarly, angles 3 and 4 are also congruent. Same reason, they're alternate interior angles. Okay, so since angles 1, 5, and 3 have to add up to 180, I could take this angle 2 and substitute it in for angle 1. Take this angle 4 and substitute it in for angle 3 in that equation. And now you see that the three angles of a triangle have to add up to 180. We got from the screen what we need. All right. So in problem 1, we are simply being asked to find these different variables. Myself personally, I like going alphabetically whenever possible. So my eye naturally goes to the x angle. What might I do in order to solve for x? Helena.
Add 32 and 46.
And then?
X equals 180.
Okay, I see what you're saying. 32 plus 46 plus x, yes, will equal 180. Fantastic. Okay, so combining my like terms, I have 78 plus x equals 180. Ladies, subtracting the 78 from both sides, I have that x is 102. And once I have x, y should just kind of fall naturally out of us. What do I notice about x and y? Is it chapter 1 still? They're supplementary. They form a linear pair, yes. So y will be 78. And then, how might I find z? Don't just give me an answer, give me a process. Let me hear from someone different. Yes, Brianna.
36 plus 78 plus z equals 180.
Beautiful, yes. 36 plus 78 plus z equals 180. Fantastic. So that's 114 plus z equals 180, and z is 66. We have from here what we need. Still getting. Okay. In the interest of time, I'm going to skip over that your turn momentarily. If we have time at the end, time permitting, I'll be happy to address that. I do want to make sure that I'm addressing the problems that are like what you're going to see in your homework. In problem 2, I'm asked for the measure of angle 1. What's the first thing you notice about angle 1? Zoe?
It's
Careful, you're combining two different concepts. We've been talking about parallel lines a lot, and we use the parallel lines to talk about the angles of the triangle, but for the purposes of this lesson, either they're angles of a triangle or they're an exterior angle of a triangle. Lily, what do you notice? Angle 1 is an exterior angle. And one of our properties of today says that an exterior angle equals the sum of the two remote interiors. Do I know my two remote interiors in this diagram?
Yes.
Yes, so I can just add them together. The measure of angle 1 will equal 46 plus 41. So that's 87. And that's all we were asked for in part A. Don't give me an answer, give me a thought process for part B of problem 2. Adrian.
I have a question.
Question, please.
If measure of angle 1 was 87, then
Answered your own question?
yeah.
Okay. Okay, so my question again to you was, don't just give me an answer, give me a process. Does someone have something that they observed in problem 2 part B that we can do in order to find angle 2? Trent. It is not supplementary to the 119. Be careful. The angle down here is supplementary to the 119. Casey, what do you notice?
Confused. Since 119 is an exterior angle, so it equals 119.
So 119 is my exterior angle, and you're saying set it equal to?
53 plus the measure of angle 2.
Beautiful. Yes. Absolutely. And then subtracting, I find that the measure of angle 2 is 66. Problem 3, I would hope you'd notice, looks a lot like that. We okay over there?
Yeah.
Okay. So as I've asked before, please don't call it out when you see it. I know some of you will see it very quickly, calculate that answer in a snap. Don't call it out. Give your neighbor a chance to look at it, notice it, observe it. And it looks like we see it. Can everyone tell me?
D.
It's D. To clarify, like I said, this one is just like that problem 2 part B that Casey talked us through. I know that x plus 60 has to equal 110, so that's why my answer is D. And we do in fact have time. Let's go ahead and address the your turn for problem 1 and 2, since Socrative is not behaving and we don't have a daily quiz.